All right, it's up. Am I audible from here?
Yeah.
That's cool. So I think it's been a long day, so I'll start with some exercises. Okay. First question: who has used any LLMs before? Be it Gemini, ChatGPT, Claude, anything? So many people have never used any of that.
Yes.
Okay,
Yes,
interesting.
use.
Interesting. Okay. Next question: who has used any AI system, not just LLMs? Systems where you fetch data, they can interact with APIs. Okay, much fewer, much fewer. And the last one: who has built one? Who has built one AI system that interacts with data? Okay. So a lot of times when you ask questions to LLMs or AI systems, you get incorrect answers, right?
Yeah.
You get some gibberish answers sometimes as well. How do you prevent that? Fine tuning, grounding, those are all correct. Yes. So before starting into that, I'll introduce myself. I'm Yash. I work in a consulting company called Vivanti, where I specialize in data platforms and AI. I'm also one of the Google Cloud Champion Innovators in Australia, who is focusing on AI ML, which is a handful of people in Australia. I have years of experience building data platforms, machine learning systems for a variety of clients across Australia. Today, we'll go through what are the limitations of the LLMs that we just talked about, not just ChatGPT or Gemini. They all have these problems. They all hallucinate. What are the problems? What is grounding? As you mentioned, what is grounding? How do you ground LLMs? What are the ways that you can achieve grounding to get more accurate results out? And finally, how do you do that on GCP as well? We want to cover, because this is a Google developers group, and we'll have a short demo showing how you can chat with documents or websites as well. And then finally, we'll have some time for Q&As. Before we jump into limitations, let's ask a question to a few LLMs and ask them who is Yash. Let's just introduce myself. I guess some of you might not be able to see it, but it's talking about some actor in India. That wasn't my intention, was it? Is it hallucinating or is it giving incorrect answers?
It's unexpected.
It's unexpected, right? It's not understanding the context. It's not understanding what is my question. It's just based on what it has learned in the past. It's looking at the history of its training and it's just generating an answer. It's not accurate. Maybe it is, but it's not accurate for the context in which we are talking about. So that's a problem. And specifically, if you build a chatbot, if you're an enterprise and if you have a public facing website and someone comes and asks, what's my plan? What SIM plan should I pick? And if they give out a competitor plan, it's not good, is it? So you always need to make sure that your systems are grounded in your own data. And LLMs don't do that. So they lack domain specific understanding. They are trained on very, very generalized data sets. They don't understand your unique terminologies as well. I'll show you one more example towards the end. But when you ask what is a rack, LLMs can come up with a variety of different answers, not just retrieval augmented generation, which is what we're talking about. It also does not have access to private data, as I mentioned. It could not find who I was because it did not have that private information, right? It lacks governance. That's what Krisha mentioned about. It lacks governance. How do you make sure that someone cannot access some parts of data sets that you have on the back end? You don't have auditability. Why did the LLM I showed before? All of these. It had Gemma, Gemini, Llama, all of them. Why did they create these answers? There's no auditability. There's no traceability of where these answers came from. So that's a problem. Again, there's a few data privacy problems, which is when you share data with LLMs, which are not in your control, then there's legal agreements that you need to come up, which is not the solution. With grounding will not solve that. But that's a problem. And now we come to grounding, which does solve a few of these problems. What's grounding? It is anchoring your model in your own data or in the real world scenarios or in your contextual scenarios to get more accurate answers. So another example from the previous talk, she gave out the schema for the database so that the LLM has a context of what query am I framing. How does it know that the column is called name? What if the tables had first name and last name? Unless you give out that context, your LLMs are not going to work for you. They would just generate something random. And there are a few ways to ground, but there's a journey for it. Starting with few shot learning, which is not exactly grounding, but I'll still talk about that. We have fine tuning. We have RAGs, which is a retrieval augmented generation, not what the generic LLMs would tell you. And then there's agentic. Everyone would have heard about agentic era, agentic AIs. Agents are the future. So we'll talk about that as well. Starting with few shot learning. What exactly is few shot learning? Yes.
You give a few examples, right?
That's okay. No animation, sorry. So essentially, you give a few examples out to the LLMs in this case, so that it mimics or it tries to act as if it knows what it's talking about. It doesn't, but it still tries to. You give out a few examples to that LLM, and it tries to replicate that pattern to generate those answers. It's usually good for simpler tasks or when you want to use it in conjunction with other methods that I'll be talking about. So I'll just go for an example rather than switching for demos. I'll just add some screenshots here. If you look at this one, in that question, I formulated question, answer, question, answer. So my first question is, this is awesome. Answer is positive. Question, this is bad. The answer is negative. So I'm just trying to do a simple sentiment analysis here. So I've just given out a few examples here and then ask the final question. What a horrible show. Oh, you can't hear. Oh, okay. Wait, so that's here. So I will keep that. Okay, so now it gave me a result saying negative. And all of them followed the same exact structure, just one word. None of the LLMs, be it open source, ChatGPT, Gemini, whatever it is, they all follow the same structure because I've given it some examples that you need a one-word answer. Next one is fine-tuning. This is where things get a bit more interesting. So fine-tuning is when you have smaller data set, but you want to train those models. So now you'd be actually training the model, updating the weights on those models. So you're actually tinkering with the model itself, not around it. It usually works well if you have output formatting, if you have styles, or if you have a lot of data. Then you can start with fine tuning. And it's like studying for an exam. You learn something and then you sit an exam based on your memory. You just write it down. That's what fine tuning is. It's just learning from that small subset of data that you gave it and there's answers. So essentially, you have a base LLM model with all the predefined weights, be it Gemini or be it Gemma or Llama or ChatGPT. They have base weights. With fine tuning, you're updating those weights based on your own data. It's a compute intensive activity. So unless you have a really good cause for doing a fine tuning activity, you have better options. And eventually, once you fine tune those weights, you can use those models to achieve the outputs that you want. This is the fun one. I like it. RAG, retrieval augmented generation. This is what we're talking about. What it does is it gets contextual information for the query that you're asking based on any backend source of information. It could be your websites, it could be structured data, it could be unstructured data, APIs, websites, whatever. So you can have all of that hooked into your systems, which gives you contextual information. And the benefit of this is it's auditable. Now, when I ask it a question, it would first go out, fetch that contextual information, and generate an answer. But this time, I know that this LLM used this chunk of passage from this URL to generate the answer, which makes it highly auditable. And it's like an open source exam, just to make it simpler, right? You have a book, you have a page, you go in an exam, you look it up. Oh, that's my answer. And you pick it up from that source. It's doing the exact same thing. So usually the workflow would look something like this. So when you ask a question, there is a retriever that sits before hitting the LLM, which looks at the contextual information, ranks your pages, ranks the documents, and fetches those documents, passes to your LLM as context to generate your answer. And what it does is it gets you more reliable answers, which understands what you're trying to achieve because it gets that relevance. Going through a lot of theory right now, but again, a lot of people don't have exposure to these, so I'll still keep talking. Agentic AI. Everyone's been talking about agents. What exactly are agents? They could be talking to APIs now. They can do actions for you. Let's say if I ask, with the same example that we had before, insert something for me. It could insert data for me. That becomes an agent. Or maybe it can update an entry for me. If I say change Elon Musk's name to something, it does that for me. It does an action on behalf of me. That is on the path of becoming an agent. Um, Again, this is very auditable because when the agent triggers a function call, when it calls a tool, you get a trace that it's using these tools with these input parameters, with these outputs. And this is how I generated the answer for you eventually. So it's very traceable, and that helps a lot of businesses or a lot of enterprises get confidence that it's not just blabbering something random. I have given out an example here, which is like it's like an open book exam with access to books and calculators, which makes sense. But while I was commuting to this, I came up with a new example. It's like a group activity where some people are good at coding, some are good at writing, and that's exactly, and some are good at project management, and that's exactly what agent tech framework looks like. There's a supervisor, let's call it a project manager. You have a coder, which is the first agent. You have a writer, who's the agent number two, and so on. So you can orchestrate all of that with a supervising agent or supervising LLM, which knows what agent to call or what tool to trigger. That makes everyone's life so much easier because you can now focus on building very specific agents or specific LLM or agent systems or AI systems, whatever you want to call it, very specific for one purpose. So let's say agent one is really, really good at retrieving data for me. It's amazing at blazing fast retrieval tools. It knows how to rank all of my content. My agent two knows my entire organizational formatting style or how I like my email to look like. So I can create a supervisor agent which then calls all of them. And that supervising agent doesn't need to be good at anything. It can be a very generic LLM who knows what to do. It just needs to know that I have access to these tools, I have access to these agents, and I just call them when I need them. Before we go into the next one, I'll just ask if there's any question, not a long one, but any confusing point until now that you've heard that you want to clarify. Yes.
You can also connect it any other system that has details. If I'm looking about what's happening with application or something, you can connect.
Yes,
Yeah.
that's right. So you can have API accesses, for example.
Yeah.
So let's say you have your Salesforce or your CRMs, any CRM, you have API access. Your agents can then call those APIs based on the input output parameters you define, and it would trigger those API calls based on what your request is. Let's say you ask, add this person from my CRM or remove this person for CRM or give me the tracking history of this. It can call those.
That's a retrieve, right? That's a retrieve.
It becomes like a retriever, correct?
Okay. And give it to the LLM, right?
Correct. Okay, so let's compare these methods and how do they handle some of the limitations. Because as I mentioned before, you're not usually going to use one or the other. You can use all of them in conjunction with each other. Understanding of unique terminologies and processes. That was a problem that we discussed. Few short learning never can understand that because you just gave it a few examples. You told it that this is positive, this is negative, and so on. It does not get those understanding, like detailed understanding. Maybe you can get that with fine tuning because you have a lot of FAQs set up in your backend for your enterprise. You have a lot of unstructured data, but then you classified them. You can do a fine tuning activity on there. Input, output, update the model weights. That's fine tuning. It can start to understand those terminologies. But again, when talking about LLMs, they don't really understand what you're saying. It's just that those weights mimic that it's trying to understand what you're saying. Then we have RAG, which is, again, as I mentioned, it brings in context, which is possibly somewhat like an understanding activity. It can understand what the context is, what is your unique ask here. Same for the agents. They can understand based on the context given to them. Accessing private data, few short, of course, cannot because you just given out a few examples and they can't. But fine-tuning RAG and agents, definitely, because you have programmed them to get access to those private data before answering those questions. I'll quickly wrap this up because very straightforward. Auditability, I've already talked about. With RAGs and agents, you can audit what it's trying to do, where it's getting those contexts from, where is it getting the data from. You can audit all of that. What tool did it call? Let's say we talk to a CRM to find out the tracking history. We can audit that, oh, this LLM called API 1 rather than API 2. You can track and audit all of that. Hallucinations, all of them do handle it in one way or the other, but it does not guarantee. So it's better to have guardrails around all of that. And this is the fun one which I want to talk about a bit, is fine-grained access control. So now that we've created retrievers, agent tools, and whatever it is, but how do you get fine-grained control? Let's say I create a website, the chatbot. I go on and ask, what is my plan? It needs to get that entry for just myself, not for you. When you go on that chatbot and ask, what is my plan? It needs to answer what your plan is, not what everyone is using or not just random thing. How do you manage that access control? So there are a few ways to handle that. One is you can pass tokens through when you're querying. You can have row level securities, you have column level securities on your backend databases. You can pass those tokens through, which can help reduce those issues of random answers. It can give you more personalized answers because now it knows when I run a query, it only gives access to these records, not these records. Grounding in GCP. This is going to be fun because a lot of people never created any LLM systems. And the first one is so easy that you can create a RAG in 30 minutes. It's called Agent Builder. It's low code. And out of the box, it gives you the ability to search, chat, create agents, and whatnot. Easiest one, searching in chats. let's say you have files in Google Drive, Confluence, or if you are already on GCP, you have files in GCS or BigQuery. Just point your agent builder to that source. Say that my files sit here. That's it. That's all that you need to do. I'm not joking. That's all you need to do. No embeddings, no retrievers. Just tell it that this is where my files lie. And it would build this for you. And the one that you see on the right, you'd get a UI like that without even trying to build anything. It just does that out of the box. And now when you ask questions, if you see there's number one, there's one or links in all of these passages. So now you're auditing where this LLM got that answer from. It gives you those links that, oh, it got this from this document or this paragraph from these documents. And it's really good. I really, really recommend if you've never built an AI system and you're doing it for the first time, just to understand how things work, go onto Agent Builder, create a search, just add 5 files in and see how things work. It's really, really good. Now coming towards people who are engineers, who have built systems before, you might have seen all the 3 logos out there. LangChain, Llama Index, Haystack, really, really good. LangChain has a really good connect, I would say, integration with GCP. So if you're trying to build an app, try using LangChain. You can do vector searches on BigQuery. There's Vertex AI vector search, which is very expensive. So unless you have a really good cause for turning that on, don't. It is going to blow up the cost on your GCP account like that. And don't try it unless you have a really good cause. You can have your vector stores in AlloyDB. You can have that on BigQuery. You can self-host your own vector source with GCS and BigQuery. You can do Cloud Runs. Cloud Runs now support GPUs. Can use any of that with GCP. And you have all of these vector source available. I'll show you a couple of examples of how these databases look like on the backend, what the embeddings look like, how the code looks like. Another cool thing that I wanted to do is Cloud Run now has GPU support. So if you're just tinkering around and want to see how Cloud Run works with GPUs, give it a try because it can scale to 0 and then back to where it was based on your requests. Let's do a face-off now. Let's see if what I talked about does what it's supposed to do. Let's go to this one. So let me zoom in a bit. Is it visible to everyone on the back? Okay, no. Let me try zooming. Is it better? Okay, cool. So now I asked the question, what is RAG? Gemma 2 had a pretty good answer. It says retrieval augmented generation. This is an ungrounded answer, by the way. So I guess it knew what RAG is already. So it was able to answer that. And on the other hand, the grounded answer does the pretty similar job, but it's using the language that I usually use. It broke down into a retriever and the augmentation and then whatnot. GPT-5, 3.5, sorry. It says it stands for red, amber, green. How many of you are from the project management teams who use red, amber, green? No one?
Right.
Yes. But the answer I was looking was RAG. So again, that's the difference between grounding and ungrounding. And I wouldn't say ungrounding, but not grounding. Same for Gemini Flash. You get a pretty decent answer. Llama 3, it goes for red, amber, green, rugby athletic group, rough around the edges. None of them make sense for the context. But if you look at all the grounded answers, they're very similar. Did anyone see that similarity? all of them had a very similar language because they picked up all of that from my
Document.
documents. Um, let's ask another question. Maybe some. Let's go back to who is Yash. It might take a while because there's like 16 API calls that go on the back end. So I will show my code in the meantime. Actually, before we go into the code, let's go into how the embeddings look like. So this is a bit more technical. So as I mentioned, we have vector stores, which stores vector embeddings along with your content, your URL, your document, and whatnot. And how the retriever works, it looks at these embeddings, compares which ones are the closest vectors. So let's say you have a 512 dimension vector in this case. Which one is the closest one? It finds all of those, gets them out as context. Your LLMs pick them up, and then create the answers based on ranking. It tries to identify what's the most relevant context from these 5 documents that I got. And the fun thing is, this is all hosted on BigQuery, which is serverless. You're not paying anything for keeping your data here. It's super cheap, and it gets expensive when you have terabytes of data. But to play around, go for BigQuery. Just try putting in your data sets in here. If you see it, it also has the content in plain English, and then there's a vector along with that. Same, this is something for weather. It has embeddings. Now it would look for those embeddings, try to find the closest one, and then answer those questions as you see. Let's see if we got the answer. No, not yet. Okay. Agent builder, as I talked before, the easiest one. Do try this out. I asked it a question: how to create a remote function. I did not tell like what remote function am I talking about, what tool am I trying to use, what database is this for. But because it's looking at all the documents that I provided, it knows I'm trying to talk about BigQuery, remote functions, and you can create it with Terraform because that's what my document was talking about. It brings in the resource code. It brings in the query that you need to create that endpoint. It creates that function. It gives you all of that with links. So it gives you a link here. You click on it to get to your website. Might take a while. Anyway, so it gives you a summary of what it found from the documents that I provided. And again, as I mentioned, there's no embeddings that I've done. These files just sit there. In this case, I've just indexed my own website. So I've just said, just look at yashmehta.au, index it, crawl through it, and get me answers. That's it. I am not indexed. I'm not written a crawler. Everything has been managed. And it's, again, as I mentioned, cheap. So if you're just trying to play around with how agents work, if this is your first time to see if it is good for your use case, if you're trying to build something, just give it a shot. Just throw your documents in a bucket
BigQuery.
or BigQuery, depending on what you're trying to achieve, and just point your agent builder to that data source, and it's going to work. And I kid you not, it takes less than 30 minutes to do this. Okay. The answers are back for who is Yash. Ungrounded answer, same. He's an actor, blah, blah, blah. But the grounded answer is this is who I am. I work with GCP. I work with these clients. I work with agents. I've written these blogs. Same for ungrounded on ChatGPT 3.5 Turbo. It doesn't know it's just saying Yash is a very common name. I don't know what you're talking about. But in here with grounded, you have all of those informations. So it's just I'd say grounding is absolutely necessary when you go away from using LLMs as standalones. As soon as you stop using ChatGPT to help you write a piece of code or to help you create your own website, you need, as soon as you get into grounding, or I wouldn't say grounding, as soon as you get into building AI systems, you need those documents, you need that data to support your applications. Otherwise, it's not going to work. It's just going to give you random answers. A couple of tips, I would say, for building your apps. So if you're trying things for the first time, if you're new to GCP, or if you don't know, or if you don't want to spend a lot of money, store your vector stores or your data on Google Cloud Storage or BigQuery. Oh, okay. Yeah, I think you raised your hand. I thought you had a question. Put them on BigQuery or Google Cloud Storage. It's quite cheap. If you don't want to spin up your VMs to host your LLMs, open source LLMs, let's say, if you want to have DeepSeek or if you want to use Llama 3, you can host them on Cloud Run or Cloud Functions with some latency, but you can still host them yourself. In a lot of cases, self-hosting does make sense. You can also use Vertex AI's managed hosting. It takes away a lot of effort from your hand. You don't need to manage any of the infrastructure. You just tell it that I need to use this LLM. It would just start the hosting on for you. If you want to stop it, stop it. Make sure that you focus on all of these serverless offerings that Google provides. You don't want to spend thousands of dollars just to play around with some LLM systems. You don't want to turn on, as I mentioned, Vertex AI vector search. Sorry. It's very expensive. So don't do that. Use these serverless offerings. And the last thing is, you saw the differences between the answers that we got from all of these systems, and they all look pretty similar, right? So does it matter what LLM are you using, or does it make sense to invest more on your retriever to make sure you get more relevant information, you get more up-to-date information, you get more governance around your data, that relevant people can access relevant information? So it's just a thing to consider. Think about what you're trying to achieve, what data you're trying to use, rather than just deciding between, oh, I'll use ChatGPT, I'll use Gemini, I'll use Grok, I'll use this, I'll use that. Don't focus on what LLMs you want to use. Focus on what you're trying to achieve. What data do you need to succeed? And I'll leave that here and go for some questions. Yep.
What's the benefit of hosting the LLM itself versus just using the chat?
Okay. Let's say you're an enterprise. You are in financial services in Australia, and you have a policy to make sure that your data does not leave Australia. And you have legal obligations to make sure that your data is secure. Sending it over to ChatGPT, you need legal agreements, you need all of that. So in that case, it's better to just host an open source model in that case, maybe. Or even if you're a Google client, maybe you just go for Gemini, because it's on your platform. You're not sending. You can use DeepSeek, self-host it yourself. You can do all of that. But in all of these cases, your data is not leaving your infrastructure. So in a lot of scenarios where you have governance, when you have compliance to follow, you don't want your data to leave. So in those cases, self-hosting is absolutely essential. Any other questions? For what? That's a very vague question, honestly. So all of these cloud providers do provide you options to save, like fine. Cost wise. Um, I'm not played around with fine tuning on ChatGPT itself. Um, I'm not too sure. Cost, I'm not too sure what's the best for fine tuning, but usually it's not about that. When you're using these systems, you're already logged into a vendor or you're planning to get a vendor. So it's not just about cost, it's about your legal obligations, it's about your data protection, it's about privacy. So you need to consider all of that before thinking about what LLMs to fine tune. But overall, Mhm. Yep. 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 I'd say Google because this is GDG. I honestly don't know the answer. I don't know the answer to that. I really don't know the answer to that. Which is the cheapest? I don't know. It is Google. Yes. It's generating answers which are meaningless. It can be meaningless in general, or it can be meaningless for your context. You can consider that as an hallucination. Just a great example. If you've been using ChatGPT for a while, in previous versions, when you asked a question, write me a code for creating a BigQuery remote function, it might bring you that code. It can write a query for you. And then if you ask, where did you get that information? It would just generate a link that never worked. It never worked. Has anyone experienced that before? Yes. Anyone else? Okay. Two people. Okay. So that happens a lot. It just comes up with its own random answers. It tries to come up with a link that exists, but it never exists. That's hallucination.
And probably take one more question.
Yes. Yes.
Do you have any recommendations on
Mhm.
how we or how we approach that?
So one way is testing your retriever in the first place. Is it actually retrieving the correct documents? Because as a lot of engineers know, data garbage in, garbage out. That's going to happen with the same thing unless you test your retriever properly. Unless you know that it's um, ranking your context correctly, it's never going to be accurate. The other way is once you have your context, because you're never going to give it one document, you're going to give it 5 documents or 10 documents or 20 documents. Eventually, when you generate the answer, you need to compare its relevance to those contexts. So there's a way to compare your output with your contexts. You measure for, let's say, 500 examples, and you see, is your system actually generating contextual answers, or is it still hallucinating, or is it using something random? So you can have your entire loop setup, which would compare your data to the context, and you can have guardrails around it to block the answers if they don't match the context.
Like agentic, right? Somebody reviews.
You can do that on agents as well. You can do it on RAGs as well. Any AI systems, you can have a loop
All right.
which compares your context with your output. So after your output has been generated, before you serve it to the user, you can have a check. And you had one more question. Yes. Sorry, I can't hear you clearly.
How is that enough time to, and how often should we? Okay. How to it? The first one is how would you do it?
Okay, so the first question there was, how do you know that the model has been fine-tuned to your requirements? And the other one was, how often should you fine-tune? So answering the first one, there's so many metrics out there. There's how many of you have created machine learning models back in the day, statistical models where you do F1 scores, ROC scores, all of that? Okay, a few. So there are metrics for LLMs that help you understand if it's creating the correct outputs. So you measure those, train it over unless you get your metrics right. How often? Again, it depends on your use case. Very generic. If you know that your FAQs are never going to grow, you know you have 500 FAQ documents, train it once. Now let's say you got 50 more documents, fine tune it again. It depends on your use case. Do we have?
One final one, so the, and I've been there for a while. Sorry,
Okay, last one.
So how to-
So again, similar to all your deep learning models, you would have early stopping criteria. You have criteria when your measures don't grow. You have iterations when you can stop. So it's exactly the same. And there are so many techniques out there these days which reduce your compute cost. So they only change relevant weights. They don't change your entire model weight. You can have all of that set up. Let's say if you're going on to fine tuning on Vertex AI, you can set up, you only want to fine tune for 5 hours, stop after that, or stop after your metric, let's say cosine is stable for 5 iterations or something like that. Does that make sense? All right. Thank you, everyone. If you still have questions, I'm around. Thank you.